All right, algebra friends, let's get started and see how this goes. We are starting in section 1 in our book, talking about functions, which is probably the unifying idea of this whole semester. Everything we're going to be talking about are functions. Before we talk about functions, we need to talk about relations. So a relation is just a set of ordered pairs, and it can be an ordered pair of anything. We usually talk about numbers in math class, but it can be an ordered pair of anything. And the set of the first components of each ordered pair is called the domain, and the set of the second components of each ordered pair is called the range. So hopefully those are words that sound familiar to you from previous math classes. So here we've got an example of a relation. We've got to have a set of ordered pairs, and in this case, the ordered pairs are made up of numbers 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. And the set of the first components, so 1, 2, 3, 4, and 5, that set of numbers is called the domain. And the second set of numbers, 2, 4, 6, 8, and 10, is called the range. And you'll notice that we have these little curly brackets at the beginning and end of each of these sets, right here and here, and here and here. And those curly brackets are one way that we denote a set in math. So that's an example of a relation. Of course, in math, we are usually interested in a very special kind of relation called a function. Okay? A function is a relation in which each possible input value leads to exactly one output value. We say the output is a function of the input. So we put an input in, the input values make up the domain, and the output values make up the range. Okay? So, and I know in previous math classes, maybe we've thought of like a function box. You put a value in, and out comes an output value, right? And the important thing about functions is each possible input value leads to exactly one output value. So one way I like to think about this is if everybody in our class, we had everybody sitting in a room, maybe we'd have 10 people, and everyone in that room has a birthday, right? So if we had somebody named Joe, Joe has a birthday, maybe it's January 7th, right? Is it possible that we also had Amy in our class? Does Amy have a birthday? For sure. Could it be January 7th? Yes, it could. Is this a function? If Joe and Amy both have the same birthday, let's think about our definition. Each possible input value can have just one output value. So is it possible that Joe and Amy both have the same birthday? Yes. Is that a problem? One input, is it possible that Joe has two birthdays? Could he be born on January 7th and March 16th? No. Of course, barring some weird like time travel thing, right? In normal life, Joe has one birthday. So an input, Joe, can only have one output value. Two people might have the same birthday, but that's okay. Okay, that would be a function relationship. One input gives you one output. Okay, you can't have one person with two birthdays. So that's an example of a function. So let's look at these examples. So in A here, we have a relation, and it tells us this is a function. Here's our inputs, here's our domain, and the relation goes over here to this range. P goes to M, and Q and R both go to N. Is this a function? Every input value has one output value. So yes, this is a function. How about this? Is this a function? Every input value in the domain, P, Q, and R, go to one output value, X, Y, and Z. P goes to X, Q goes to Y, R goes to Z. Yes, it's a function. Let's look at this one. Here's our domain, here's our range. P goes to X, but Q goes to Y and Z. No, can't do it. It's not a function, okay? Every input value can only have one output value. right? This would be like saying Joe was born on January 7th and March 16th. Can't happen, okay? So functions are a special kind of relation. All of these are relations, okay, but only the first two are functions. So let's look at a menu. Here's an example. We've got 3 items: plain donuts, jelly donuts, and chocolate donuts. And here's their prices. So here's, we've got ordered pairs, right? Plain donut, an item, and a price. Plain donuts are $1.49, jelly donuts are $1.99. Right? We've got 3 sets of ordered pairs. This is just, so here's our, so is this a function? Well, the first thing we could ask is which direction, right? Let's see, if our input is the item and our output is the price, is this a function? For a plain donut, is there only one price? Yes. For plain donuts, it's $1.49, jelly donuts, $1.99, chocolate donut, $1.99. There's no ambiguity, right? This is a function in this direction. If our input, if our domain is items, and our range or output is price. What if we go the other direction? We just have, if our input is price and our output is item, if I said it costs $1.99, what item is it? I don't know. It could be jelly or it could be chocolate. It's hard to tell. We can't tell, right? This direction, if this is our domain and this is our range, it is not a function, right? It's a relation. It's not a function because this price gives us 2 possible outputs. This input gives us 2 possible outputs. One more quick example. What if we had this grading scale? So here's, if you get it, this is your percent grade. If it's between, this is made up, not for this class. But if you get between 0 and 56%, you get a 0.0, and so on. 72 to 77, you get a 2.5 for your GPA. And that's how it works. Is this a relation, right? Is this a function? Well, again, it depends which direction, right? If we said the input is a percent and the output is a GPA, if I said Joe, I guess we'll use Joe again, got an 89 on the test, what's his grade point average, or I guess in the class? Well, you go over here and say, well, 89 gives him a 3.5. Right? What if I said Sue, her grade point average, it was a 2.5. What did she get in the class? And you say, I don't know. It could be 72, 73, 74, 75, 76, or 77. Right? So it depends which direction. If our input is percent and our output is grade point average, we've got a function. If our input is a grade point average and our output is a percent, it's not a function, right? Because one grade point average could give you any number of percent grades. Okay? All right, so that's the definition of a function, and we are going to work with that a lot this semester.